we were looking at volumes, weren't we? So we had a region. We might have, let's say we had y equals x squared, y equals 9, x is greater than or equal to 0. One of the hardest parts, I think, about these problems is understanding what the region is that they're talking about. So if I give you that information, and I want the region bounded by those equations, what region am I talking about? Okay, everything has to be positive. X is greater than or equal to 0, that's true.
The x-axis is the same.
Okay. Well, we know what y equals x squared looks like, correct? Y equals x squared looks like that, sort of. Well, yeah, my parabola wasn't so great, but it's okay. How about y equals 9? What does y equals 9 look like? It's a horizontal line. Looks like so. That's pretty easy. I just went right along the line on the paper, except near the end there. I goofed it up. And then x greater than or equal to 0.
So everything above the x-axis, but in that little area and beneath the line.
Correct. So the region we're looking at is above the parabola, but below the line.
Oops, no, I was talking about, yeah.
And it's in the first quadrant, so it's bounded by the x-axis also, so that's go that way. All right, so,
oh, yeah.
because it says x is greater than or equal to 0.
For some reason I think the line.
All right, so let's say this is where we were the other day. This is where we were, I don't even know, Wednesday, yesterday. All right, so we were doing things like, let's say we take that and we spin it around the x-axis. And we were finding the volume. And what we did is we said you have to consider one little rectangle. Here's what one little rectangle within that region would look like. So if I'm spinning around the x-axis, am I going to have a solid little cylinder, or am I going to have a washer? Absolutely a washer. How do you know it's absolutely a washer?
Because there's a space.
There's a gap. There's a gap right there. So this is going to be a washer. So what we needed to do is we needed to find the volume of taking everything under the line and spinning it around. So we need to take the volume of a little strip that looks that long, and then we need to cut out that little piece right there. So our answer was going to be volume is pi times the integral.
Will you always be telling us that we're looking at around the x-axis?
I will always tell you which line you're spinning around. Absolutely. Without that information, you can't answer the question.
But I was thinking y, so I don't know.
Good.
That would be solid, right?
If that was right at 0, it wouldn't be a washer, right? Because there'd be no space.
I would agree. Right at x equals 0, you wouldn't have a washer.
Yeah, but then you don't have...
But remember, it can't just be really right at x equals 0, because you have to build a rectangle, so it's got to have a little bit of width. So if I have just a tiny little bit of width, then there is just a tiny little gap there, isn't there?
Because mine has no width, so that would be 0.
Correct. If I just have this line, then there's no width, and I don't have a rectangle. All right, so our volume is pi times the integral of the long, the big thing. How long is the big thing? 9. So that's going to be 9 squared minus, then we need to cut out that part right there. So how long is that? No, 9 minus x squared would actually be this length. This length would be 9 minus x squared. But that's not what I need. I really need just this length right here. That's just x squared, isn't it? Because you go from x squared to 0. So the length of that little piece right there is x squared. So we're going to have x squared, squared.
It would be x squared minus 9 minus x squared. So that would be...
Too complicated is what that would be. Just call it x squared. One thing's missing. Well, actually, two things are missing. What's that? The interval. Where does it start? It starts at x equals 0, ends at x equals 3, because they would intersect at 3, 9, wouldn't they? All right, so that's kind of where we left off yesterday. Of course, we talked about spinning around other lines also, other horizontal lines. What we're going to do today is we're going to talk about what if I want to take that same region but spin it around a vertical line. We don't. Well, you don't. I do. I want to. So I'm going to give you the exact same region. Y equals x squared. Y equals 9. X is greater than or equal to 0. So it's the exact same picture.
Now it's going to be solid.
Well, it depends on what line I spin it around. But the first one's going to be solid because for the first one, I want to spin it around the y-axis. In order to spin it around the y-axis, in order to make a disk or a washer, I need to build my little rectangles this way. As soon as I have to build my little rectangles that way, that changes something dramatically. What does it change? Instead of having dx, we're going to have dy, which means we need every formula to be in terms of y's, not in terms of x's. All right. So if I'm building my little strip this way and spinning it around the y-axis, do I have a solid cylinder or do I have a washer? It's a solid cylinder. Why is it a solid cylinder? There's no gap. It goes directly to the line where we're spinning. No gap anywhere. All right, so my volume is going to be pi times the integral, and I know on the end I've got to have dy. So now the question is, how long is that little strip that I drew? It's the square root of y, because we would write this equation as x equals square root of y. And then how it goes from square root of y to 0. So its length is square root of y. So we're going to have square root of y squared, which is just y, which this problem works out nice and easy, doesn't it? We like that. Interval, what are my bounds of integration? 0 to 9. Excellent. Why is 0 to 9, not 0 to 3?
Because it goes up, down, instead of over.
Because now we got to use the y numbers. So now we go from the lowest y number. The lowest y number is 0. The highest y value is 9. Grace?
What if you rotated the graph or over one and then you use x's? Would you get the same value? I don't know, it would be a different function, but
Are you talking about what if I rotated the graph 90 degrees and then rotated it around the x-axis?
yeah.
Yes, absolutely. You would have the same shape, same thing. Because it would look like this. But now the question would be, you got to find the equation of that curve.
Which is the square root of x.
You got to find the equation. I don't think that one would be square root of x. I don't think so. Square root of x looks like this. Square root of x goes that way.
So it would be negative square root.
It could be negative square root of x. Yes. So you could do it that way, but you don't want to. That's harder.
Would you be solving for the wrong, for a different? Do you think that point if you did it that way?
It would work. You'd get the same answer.
So if we got the same
But
answer,
x
but
is greater than 0, so we can't actually solve it.
True. We would have an issue with negative signs doing it that way, wouldn't we? Anthony?
Since we're dealing with like curves, are we ever going to have like sine and cosine waves? Or is that a higher math?
Oh, what a wonderful idea.
That sounds like a terrible idea. Why did you ask that?
All right. Well, let's just pick an easy one. Y equals sine x.
could you even do it if it was like tangent of x and it was an asymptote?
You would have to stay away from the asymptote. But yes, you could. Y equals sine of x. 0 is less than x is less than, we'll go from 0 to pi, perhaps.
But if the asymptote is in the middle of the interval, you can't do it?
Correct.
Or would that just break up into two?
No, if the asymptote's in the middle, you can't do it. Absolutely not. Not in Calc 1. When you take Calc 2, you can. There are ways to deal with asymptotes. We handle those in Calc 2. All right. What does y equals sine x look like between 0 and pi?
It's going to be
Sine wave 1 and
It's a sine wave,
just one.
and I think 0 to pi, I think pi is right here. So you just get the
Positive.
top half of the sine wave.
Because it goes from the full length, what do you call it? Full goes from 0 to
Period. One cycle.
yeah.
One cycle is 2 pi. Correct. All right. What line do you want to spin it around? The x-axis. All right. The x-axis seems like it would be a pretty easy one. Why? Because when I build my little thingy here, do I get a disc or a washer? I get a disc because it's solid right down to the line of revolution. No gaps at all. So, seems as though it should be a pretty easy problem, actually. Volume is pi times the integral from 0 to pi of sine squared x
Wait, can you take the
dx. Now comes the difficulties.
you can't do that right now, can you?
Oh, you can.
I mean, it's called square.
It is not a U substitution problem. That's a good idea. The problem is not U substitution.
I was saying,
If,
can you?
Grace,
Okay.
we will get to it. Relax, okay? If I let U equal sine, then du would be cosine, right? And I don't have a cosine anywhere in this problem to balance that out with. So U substitution is not going to work. What does work? There's no chain rule for antiderivatives. There's only chain rule for derivatives.
Well, sine squared isn't that same thing as
Sine squared is not the same as tangent.
So it's
What you can do, sine squared is the same as 1/2 times 1 minus cosine of 2x dx. And that's known,
So cosine squared is 1, right?
sine squared plus cosine squared is 1, right?
no, notice it's not cosine squared, it's cosine of 2x. This is, from your vast knowledge of trigonometry, this is called the power reduction formula.
What?
Power reduction formula. So there are two of them.
I remember 1 minus cosine.
Sine squared x is 1/2 times 1 minus cosine of 2x. And cosine squared x is 1/2 times 1 plus cosine 2x. And those are known as the power reduction formulas. They really come from the double angle formulas. So that's how you would handle a sine squared. What you have to do is you have to reduce the power by using the power reduction formula.
Would you give us those on the test?
I would not give you those on a test.
Would we need to know these for the...
You will not need to know these.
Okay.
Next semester when you take Calc 2, Mr. Evans will give these to you on a test. But you can actually do these problems in Calc 1. But this sort of power reduction idea of the sines and cosines, that's traditionally covered in Calc 2.
So we won't need to know how to do, like, find the area of a sine graph or a cosine graph.
Correct. On the exam, you will not be given... Well, actually, maybe I will. Because on the test, remember, on the test, the directions are going to be
Oh, just put it in.
stop right there.
Okay.
So on the test, I could actually give you any function I want, because you get to stop right there. It doesn't matter if you can find the antiderivative or not. Okay? But now, this cosine 2x, this now becomes a U substitution problem. Because it's not just cosine x, it's cosine 2x. So you actually do have to still do a U substitution in order to evaluate this integral. I'm not going to work it all the way out, but you could. All right, now, let's say I was in a really foul mood.
Let's see the word.
Let's say I wasn't. Let's say I was. Let's say I was in a really foul mood, and I said, I want you to take that same picture and rotate it around the y-axis.
Let's do the wash.
Okay, first off, your strip has to go the other way. And I agree completely. You're going to have a washer because there's a gap. But it's worse than that. Why? Because I don't know how to do it. That's always a bad thing.
There's no second line.
Yeah, sort of. First off, as soon as I build my strip this way, what's the huge thing that changes?
It's got to be in terms of sine y.
Everything has to be in terms of y. So I'm going to have to take this equation right here, and I'm going to have to get x all by itself.
We don't know how to do that.
Yes, you do.
Reverse sine.
X would be sine inverse of y. And now you have a huge problem because we have never talked about derivatives or antiderivatives of inverse trig functions. So this would be a problem you cannot do. Okay?
Do it like Calc 2 or Calc 3?
No, you can do it in Calc 1. Come back tomorrow. And we will learn a different technique for finding volumes that will allow us to answer this question. There is another technique besides the discs and washers method. Come back tomorrow.
So it was kind of like Simpson's rule.
Nope, nothing like Simpson's rule.
Well, is the top of it like going to be arced? And they're going to
Oh, it's fine to be arc lengths and stuff, right?
And we'll do arc lengths too. We'll do that next week. All right. So anyway, that's kind of a preview of where we're going. There will be another technique. Shells and washers. You can't do every problem with shells and washers or discs and washers. You need something called shells, and that's what we'll learn on tomorrow. Okay. All right, but let's do one more where we're spinning around the y-axis. One that we can actually do it. How about? I don't know. Anybody got a good function? Y equals x cubed. Okay, and then we need to put some bounds on that. So let's bound that by, let's see, y equals x cubed looks kind of like this. So how about we stop it over here somewhere? And we'll use this area. So let's stop it at x equals, what number do you like right there? 2. Okay. And this time, let's say, well, for the first one, we'll do it around a couple different ones. Let's say we want to spin it around the y-axis. And then we'll pick another vertical line. We'll decide on which one we like here in a minute. So, if I'm going to do it that way, then my strip goes this way. Which tells me right away I need to use washers. And I also need everything in terms of y, because I built my strip horizontally. All right, so volume is going to be pi times the integral. All right, so washers, again, I got to think of the long one. The long one goes from furthest away to where I'm spinning. So the long one looks like that. So how long is that?
2.
That's 2, right? Because this is the line x equals 2. So that's 2 units. So that's going to be 2 squared minus, and then I need to cut off this length. So how long is it from there to there? It is x cubed, except we're not allowed to use x cubed. We have to write it as cube root of y. We need to put everything in terms of y's, because on the end we have dy. So we're going to have cube root of y squared. dy, correct? Absolutely, you would rewrite that as y to the 2/3 if you actually had to do it. So we would write this as pi times the integral of 4 minus y to the 2/3 dy. That'd be fine. But we still need our interval. We still need our bounds of integration. 0 to, not 2. 0 to 8. Excellent. Y 0 to 8. It's got to be the y values. The lowest y value is 0. The highest y value is 8. All right, and that's a very easy mistake. You're so used to using x's that it's very easy to write 0 to 2 there. Watch that. If you're using dy, make sure your numbers are your y values. All right, now let's take that same exact picture and spin it around a different line. The origin is not a line. The origin's a point. A different vertical line. Give me a vertical line that you like a lot. X equals 7? All right, so x equals 7 would be way over here somewhere. Now we're going to spin around that line. So if we're going to spin around x equals 7, my first question is it a solid washer? Or is it a solid disc, I mean? Or is it a washer?
Washer with a very large hole.
It's a washer with a very large hole, isn't it? Because all of this distance here, that's all going to be one big hole, and we're only going to have a little bit of actual solid material coming around. All right, so our volume is going to be pi times the integral. And on the end, I know I'm going to have a dy.
The integral is still from 0 to 8, isn't it?
Excellent. The integral will still be 0 to 8. That's not going to change at all. Our y numbers, our lowest y number is still 0. Our biggest y number is still 8. That will not change at all. All right, what's my big function? 7 cubed. 7 cubed? 7 squared, nope. Because 7 would go from here all the way to there. I don't want to go that far. 5 is the short distance, isn't it? So 5 is our short distance. We need to go from here to there.
7 minus x cubed.
7 minus, you can't use x cubed.
Cube root of y.
7 minus cube root of y would be that length. It's always going to be the right hand end minus the left hand end. So that's 7 minus cube root of y. That's the big radius. Minus the smaller radius would be from here to here. That distance is 5. 7 minus 2 is 5 squared. 7 minus cube root of y, entire thing squared. Yep. Yeah, I snuck that in there. I might not have said it, but I did write it. I snuck it in there. All right, so this one would be a little bit difficult to evaluate. You'd have to FOIL this out. You're going to have a whole bunch of roots to deal with. But it is one you can do, and there's no u substitution needed. It's not so bad. But at this point in your life, you do not have to solve them. That's correct. On your next lab, you will get the pleasure of solving them.
What was it?
I thought you said it was easy.
I did say it was easy. Why would it be easy if you're doing it on your lab? You got Wolfram Alpha right in front of you. You type it in and you ask Wolfram Alpha, what's the answer? And there it is. See? Easy.